Factor theorem.
Yeah, it's cool on that. Get that.
Hi guys, it's really good to join the department. I'm really excited to be here. Super excited. Sheffield great, and we're going to be great people and work together and be best colleagues for life ever. Go, Kes Maths.
Right. What's this idea?
Well, you know how teachers pay not so good, and we're really great stats teachers.
Yeah.
Let's be YouTube vloggers.
Good idea, Mr. Brown. I quite like that.
It's Mr. Barker, like B-A-R-K-E-R, Barker. Much like Fame, remember my name. Because winners draw sketches. I think I'm going to try and get that going this year. Anyway, people get paid for the views on YouTube. So if we just do loads of lessons on YouTube and we make the kids watch it to learn, then they won't have a choice. And we'll get loads of views, we'll get loads of money, and then, you know, if we like it, great. If you miss some registers or something and it's not for you, you can just take the money from the videos.
Sounds alright to me.
Yeah, sounds good.
I can tell. Oh, you guys, we're going to be such good friends.
Yeah, anyway, back to this.
Oh, he talks a load of rhubarb, that Barky, doesn't he?
How are we going to get these views though? I mean, what can we do to
Make it entertaining.
yeah.
True, but you don't want to peak too soon.
Yeah, so we can make the first two videos really dull. The mode, our first measured location, is the value that occurs most often.
Yeah.
I'm quite happy to do that.
It's not like they can stop watching. We're making them watch.
I reckon you'll be good at that bit.
Yeah,
Yeah.
I think I would, yeah.
Yeah.
Just keep it plain.
Yeah.
I don't want to upset you, but I think you might be.
But yeah, just make it like, if you're going to describe a video by an item of clothing, cardigan. Go for cardigan in the first
Cardigan.
video.
Okay.
Definitely the first video is a cardigan.
Do a bit of rhubarb in the next few.
Yeah,
Mess
we
it up a bit.
can rhubarb a few. And then,
What hit them with the episode 3.
Oh, episode 3.
Oh, episode 3 we're going to wrap. BAM!
Yeah.
Right, let's do it. Q1.
Go.
Go team.
Yeah.
This is kicking off.
Yeah.
Yeah.
And they won't see it coming, will they?
Right, see it coming. It's almost coded.
Yeah.
Yeah, well, coding, that'll be about video 5 probably,
Yeah.
roughly.
Yeah, video 5, coding.
Okay. Kick off on that one.
Oh,
Yeah.
I reckon one of us must be angry enough.
By the time we get to video 8 or 9, they'll watch any old rubbish, won't they?
Oh, we could be doing anything. We could be like running around the school.
Yeah.
Just recycle that same idea as well. Just go for the same jokes every
Yeah.
time, same
Yeah.
outtakes, you know.
Yeah.
We're not funny enough to stretch anything else out.
So, how are we going to actually make some money from this? I don't understand.
It's alright, lads. You got to trust me here. The way YouTube works, alright? The number of views a video gets normally distributed.
Nice normal distribution, Mr. Barker.
Good drawing.
Thanks. I'm brilliant at these. Then they pay, well, let's say about 2/3. 2/3 of the people who get views, because they don't want to pay everyone. To really get the money though, you got to get at least the mean number of views.
Okay.
And then as you hit in pay brackets, the more views you get, the more steps forward you take. Kind of pretty much aligns itself to the number of standard deviations you are.
Okay.
So once you've worked out mu and sigma, then you're golden. That'd be this mu here and this standard deviation here
Okay.
that we don't yet know.
So, if we could had a method for working out this unknown mu and this unknown standard deviation, then would be in luck.
Okay, in this example, it's the same as the previous ones. We're going to use the same method, except this time we're missing our mean and we're missing our standard deviation. Okay, now like everything, drawing pictures is the key thing. Okay, so first of all, I've got a random variable x, and it's normally distributed, mean mu and standard deviation sigma. So I'm going to draw that on here. It's not really the best drawing, but I don't care. as long as I get an idea of what's going on. So that's my x distribution, okay? And it's mu and sigma, okay? Great sigma there, me. Right, and I've got two situations. I'm going to consider the first situation, where x is greater than 35, we've got probability of 0.05. That's a very small probability. So greater is small, so I'm going to have to put it over this side, okay? This is 0.05, this area, this probability. And this is the value 35. Okay? Well, I can't do anything with that. So what I'm going to do, I'm going to match this up with a standard normal distribution, okay, a Z1. Okay? So there'll be a some value of Z which will match up with this probability of 0.05. Okay? Well, I look in the little table, and see that there, and it's just over here. We get 1.6449 for our Z value. 0.6449 for our Z value. Okay. Right, so I can find a formula to link these together. Okay, this Z value matches with this X value, and our formula says to get to the Z value, take the X value, take off the mean, divide by the standard deviation. Okay. So what's going to happen now is I want to substitute those values in. So Z is 1.6449. That equals X, which we know is 35. So I should put that in as 35. Minus mu over sigma. Right. Now my advice when you've only got anything like this in these situations where there's two and you're missing both, make the mu equals here. So I want to times by sigma, and so I'll do some jig around with the sides, and I get 35 minus this horrible amount of sigmas. My sigma there. Okay, so that's like kind of one half of the problem. And I'm going to do the same with the other situation. So this says, start with your x distribution. A lovely normal distribution. It's not great, are they? Definitely should be going up again. Going down. We've got mu, and we've got our sigma. Is our x distribution. And this time we said, x less than 15 is very small. Okay, well, very small, 0.1. Just left and a half, so it must be down this side somewhere. So that value there, that area, that probability, 0.1469. Okay, and that matches up with 15. Right, well, let's go to our Z distribution. Standard distribution. And it's got mean of 0 and standard deviation of 1. Should have put that on the other one as well. And we'll have something that will match up with 15, with the same area. Okay. So the area of that's 0.1469. If I'm being clear with my working there. So the value that matches up with that, well, it's hard to say. So I look in my table and I can't find that out. I look in this big table because it's 4 decimal placing and it's not there. And then I remember, okay, well, what this big table does, it finds the area before, which I want, but it only works if it's over halfway. So I do a bit of a flip round. Okay. By symmetry, I can say the value on the other side. This is obviously the same curve. And there'll be area on the other side of it. 0.1469. So what I'm going to do, I'm going to do 1 minus it to find this area before, which is 0.8531. And 0.8531. Okay, you probably can't read that on there, but that's what it is. And I read that off the table. 0.8531 is up here somewhere, 1.05. So that's Z by 1.05. Remember, we flipped that round. In ours, it must have been minus 1.05. Well, that's 0, so it's the other side of it. Okay, let's use this formula for here. So we get Z equals X minus mu over sigma. Put our values in. Remember, we're minus 1.05 for Z equals the X value 15 minus mu over sigma. Take my advice, rearrange this to get mu equals. Okay? So mu equals, and that will end up being, if we do a jig around with it, we'll get 15 plus 1.05 sigma. So I've got two simultaneous equations to solve. Now, if you took my advice and made them both equal to mu, I can say they are both equal on the other side as well. So I can put this side equal to this side. 35 minus 1.6449 sigma equals 15 plus 1.05 sigma. Well, that looks messy. That's me putting them together. Okay. Now if you solve that, you'll be able to get sigma out. So you have to add that stuff onto there, get a horrible amount of sigma. So over to 15, you get 20 on that side. Do a division, and you get sigma out as somewhere around about 7.42, blah blah blah. I want to get that to 3 significant figures. Substitute that back in, just using your calculator, do 15 plus 1.05 times the answer, and you'll end up with 22.8. And once again, 3 significant figures. It does carry on, I'll write them down proper out of space. Okay, so key thing, two situations. X distribution, Z distribution. If you have to draw another diagram, do it. Then use the formula, get you 2 equations, make mu equal like I did, then set them equal, you can find sigma, then you can plug back into either that one or that one to find mu. Between the both if you want to check. Simples. Oh, look at the views on that.
Yeah, yeah. 50 views.
Already. It's only just gone up.
It has, hasn't it? What's it now? 100 views.
It's gone up, just refresh F5, refresh it.
1,000 views. I don't believe this.
It's getting viral.
Yeah. 20,000 views now.
Mate, I've just got a notification on my phone.
Yeah.
It's all over Twitter, it's trending. It's trending all over Twitter.
It's 500,000 now.
Oh, I've just...
500,000.
Oh, it's all over my Snapchat story.
I just wasn't expecting it to be this big.
No.
No. I mean, I knew Justin Bieber was popular, but not that popular. Should we see how we're doing with our flip learning?
Yeah, let's check out our video's doing.
10 views. That's alright, isn't it?
10 views. 40 students doing flip learning, 10 views already, that's pretty good. Yeah, I suppose they've got a lesson next, but like a quarter of them seen it,
Yeah.
so probably work alright.
Yeah. Okay, let's look at this normal distribution question in context then. So we're given that the length of fully grown sticks of rhubarb are normally distributed with a mean of 30 and a standard deviation of 2.5. So let's call this continuous variable x, and so we know it's normally distributed with a mean of 30 and a standard deviation of 2.5. So we can write that down. We want to find the probability that a stick of rhubarb chosen at random is longer than 33 centimetres. So if we draw our picture, then we've got 30 in the middle and 33 will be this side, and we want the probability that's bigger than 33, so we're going to shade in this side. So this is the probability that x is bigger than 33. So we standardise, and remember that means that we subtract the mean and divide by the standard deviation. So we're going to do 33 minus 30 over 2.5, and that comes out as 1.2. So we'll get 0 in the middle, and the 33 will turn into 1.2. And the key is that this is the same probability as this one. So if we want to find the probability of this, probability that x is bigger than 33, then that's the same thing as finding the probability that z, for our standard normal distribution, is bigger than 1.2. Well, to find that, we look up 1.2 in the tables, but that would give us the probability that z is less than that. So we would then need to subtract it from 1. Well, if we go to our tables, we look at 1.2, it gives us 0.8849. So we get 1 minus 0.8849, and that gives us a probability of 0.1151. Okay? Right. Let's have a look at part B then. It says find so rhubarb is at its tastiest if it is between 26 and 36 centimetres long. Find the proportion of fully grown sticks of rhubarb that are in this range. Now, don't be put off by the fact that it says proportion. That's just the probability that is in this range. We can express it maybe as a percentage or something like that, but it's still the same method. So, if we're going to draw a picture of this, we want the probability that x is between 26 and 36. So if we were to draw a picture of this, then we've got 30 in the middle, here is 36, here is 26, and we want it to be in this range. It's going to look like that. So let's do our standardising, and so we're going to get 0 in the middle. If we do 36 minus 30 over 2.5, that comes out as 2.4. So 36 will turn into 2.4. And if we do 26 minus 30 over 2.5, that comes out as minus 1.6. And so 26 will turn into minus 1.6. And again, we want this same range. So what we actually want to find is the probability that Z lies between 2.4 and minus 1.6. Now this is a bit trickier to do. And I think about it by turning it into two separate pictures. So let's find the probability that Z is less than 2.4 first. So that bit I'm going to do down here. And so if I draw a picture for that bit, 0 in the middle, there's 2.4, so I want to find all that probability. Well, I can just look that up in the tables. Probability that Z is less than 2.4. When you look that up, you should get 0.9918. So what we're left to find is we want to find this bit here, and then we want to take that away. So if I want to find that probability there, well, I can't look that up in the tables. So let's use our symmetry and know that that is the same as this area here. Okay, so these two areas are the same probabilities. So, but if we look at 1.6 in the tables, that would give us all this, and so we'd have to take it away from 1. So the probability that Z is less than minus 1.6 is the same as the probability that Z is bigger than 1.6, which is 1 minus the probability is less than 1.6. So let's look up that in the tables. Go to 1.6 and it gives us 0.9452, and we do 1 minus that and it comes out as 0.0548. Okay. So we now need to put this all together. So I'm going to do this up here. So we've got the probability that X is between 26 and 36 is the same as the probability that Z is between 2.4 and 1.6, minus 1.6. But we know that's the probability it's less than 2.4, which we got was 0.9918, minus the probability it's less than minus 1.6, which was 0.0548. And when you stick that in your calculator, it comes out as 0.937. So therefore the proportion is 93.7%. And that's it. So it's the last S1 video. What are we going to do?
Well, yeah, well, I'm really excited actually because I think it's gone really well there. We've
Yeah.
got loads of kids on board,
Yeah.
all those views on YouTube.
I know.
It's pretty good. Like all the
Yeah.
staff seem motivated by it.
Yeah, it's been really successful, hasn't it?
Yeah, and no one's really noticed us like having a go at some of the other departments in school or anything.
Yeah, we've got away with quite a lot, really, haven't we?
Yeah, and no one's noticed. No one's seen any staff or anything. It's really
Yeah.
said anything.
So.
Hello Malarkeys, how are you?
How's the SD?
What's this all about, this video in? And it's all about flip, is it flip learning or flip?
Flip learning, yeah.
Are you sure? What's this all about?
Oh, it's just to help the kids here. We've been.
Helping kids.
Yeah, they watch the videos.
My times, we have that would never happen my time, young man. Stop this video in, stop this flip charting. What, flip charting or flip learning?
Whatever you say.
You must stop. And the most important thing, tell that bloody Barker, take his bloody register. He always forgets. Did you hear that? Go back to good old days.
Yes, sir.
Is that clear?
Yes.
Thank you.
12-year-old.
Go then.
Oh, factor theorem, that's nice, isn't it?
Yeah, not bad on that one.
Hi guys, it's really nice to join your department. I'm Mr. Barker. It's really nice to be here. I've got a great idea how we can be best friends and work together for life.
Okay. That's your idea.
You can't laugh. I was just supposed to say that. I just watched him pan it out. He didn't do that.
Hi guys.
I couldn't just have a quick check. I won't have to get rid of this. You have to be careful with this if this is.
Have you seen Mr. Dawson office? See you next week.
Incidentally, when we're doing these videos for YouTube, for teaching, I just think it'd be great if we really repeated and emphasised obvious things that they need to learn really slowly and obviously. That would be useful. That would be a useful trick.
So if we repeated things and emphasised them.
Yeah, so like when we're saying mu and standard deviation, sigma.
Okay.
If we're ever trying to do a video and something doesn't go right, maybe put some outtakes at the end.
Yeah, that's a
That'd
good
be a very
idea.
good idea.
And just cut out stuff where we
Where we
swear
get it
up.
wrong, just cut it out.
Yeah.
Cut it out. And outtakes at the end, we can just shove it all in. They'll love it. Alright.